Hello, this is a short video summary of BOF 2A, Incorporating Parallel Computing in the Undergraduate Computer Science Curriculum. While COVID-19 prevented us from having an in-person discussion of this topic at SIGCSE'20, we hope that this short video will be helpful for faculty who are looking to integrate parallel and distributed computing, or PDC, into their classrooms. One of the reasons why many computing faculty are focused on rapid integration of PDC topics has to do with the new ABET curriculum guidelines for computer science or similarly named programs, which state that CS students should receive exposure to parallel and distributed computing. Considering the level of preparation departments have to undergo for a single ABET visit, it's no small wonder that many faculty are feeling anxious and trying to pick apart this language. For example, what does exposure to parallel and distributed computing really mean? What are the best strategies to employ? Is it at all possible to rapidly integrate PDC into my classroom? While we are hoping to discuss these topics more in depth at our Birds of a Feather session, we will instead outline some key strategies and free resources that faculty may find helpful. If you are particularly interested in interactive discussion, keep your eyes open for a soon-to-be-released email on the SIGCSE mailing list. CSinParallel will be conducting a virtual summer workshop on strategies for incorporating PDC and plans to send details out on it soon. Since one of the goals of CSinParallel is to help the CS community integrate PDC topics in the undergraduate curriculum, we are especially interested in hearing from you about your needs, your concerns, and what you feel is missing to aid you in meeting the new ABET requirements. When thinking about how to integrate PDC, there are two documents we encourage you to focus on. The first is the ACM-IEEE Joint Task Force on Computing Curricula's 2013 report, more commonly known as CS'20 which recommends that CS students be exposed to at least 15 hours of PDC in their undergraduate curriculum. CS'20 defines several PDC knowledge units and associated learning outcomes. Each learning outcome is classified as either core, Tier 1 or Tier 2, or as elective content. CS'20 recommends that a CS program covers all Tier 1 content, at least 80% of Tier 2 content, and a significant component of elective topics. From our analysis of CS'20, the Tier 1 and Tier 2 learning outcomes primarily focus on multi-core computing, though there are some learning outcomes related to distributed computing. The other useful document to check out is the NSF-IEEE Curriculum Initiative on Parallel and Distributed Computing, which was released in 2012. They identified over 100 PDC topics and recommended which undergraduate courses were best suited to introduce them. Broadly, TCPP organizes the PDC topics into 4 topic areas: architecture, programming, algorithms, and cross-cutting advanced. Each topic is also given a Bloom's taxonomy classification. It is important to recognize that the TCPP 2012 report predates CS'20, and that the PDC learning outcomes in CS'20 are distilled from the TCPP recommendations. Therefore, we recommend that you primarily use CS'20 to identify important learning outcomes, and then use the TCPP report to figure out what courses to introduce specific outcomes. The last part of this video presents some freely available resources that you can use to start incorporating PDC into your classroom. The first resource we highlight is CSinParallel, which offers a set of free modules that have been tried and tested at various institutions in the Midwestern United States. Each module contains all the material an instructor needs to implement it in their course, along with a detailed web-based description for students. Unplugged activities are another way to introduce PDC in the classroom. PDC Unplugged contains a curation of nearly 40 activities gathered from a survey of the PDC literature. Each activity contains details for implementation, mappings to CS'20 learning outcomes and TCPP topics, available assessment, appropriate citations, and notes on accessibility and recommended courses. Visitors can also filter activities by specific CS'20 learning outcomes, TCPP topics, recommended courses, and by senses and communication mediums. Some free textbooks aimed at undergraduate students contain chapters related to PDC. For example, Dive into Systems is a free online textbook for computer systems that contains chapters on multithreading and provides a broad overview of other PDC topics. Faculty teaching operating systems should check out Operating Systems 3 Easy Pieces, which offers in-depth coverage of concurrency topics. For additional ideas, check out the courseware search on the TCPP Curriculum Initiatives page. You can filter by file type, course, and other settings to view related artifacts deposited by instructors teaching PDC. If you are in need of cluster compute resources for teaching PDC, check out the CEDAR Cluster and Exceed projects. Both projects make it possible for educators to request allocations and accounts for their classrooms and students. That's all for now. If you have any questions or would like to continue the discussion further, please do not hesitate to contact us.